So a few examples. We've got a straight line here and we've got some angles along it, and we need to find out what the value of x is. So as we were doing last week, I'm going to do step 1. I'm going to add together what I have already, which is 32 and 56. And let's see what we get there. So adding those two together, I get 2 and 6 is 8, and 5 and 3 add together to give 8 as well. So we've got 88. But my step 2, I've got to do 180, take away 88 to give me my angle x. So let's have a look what we get there. So 0 take away 8 I can't do in this situation. So I'm going to borrow from there. 10 take away 8 is 2. 7 take away 8 I can't do in this situation. So I'm going to borrow from there, which leaves me with 0 there, and 17 there. That's a 17. 17 take away 8 is 9. Okay, so I've got 92 there, 92 degrees. Does that look reasonable? Yes, it does for the picture. That looks just a bit bigger than a right angle to me, so that is 92. So my x angle is 92 degrees. Just to point this out here, if you ever see a picture in a test paper that says not to scale, then it literally means you cannot put your protractor on here and measure it and put the x's, whatever your protractor says it is. If it's not to scale, that means they are expecting to see sums written out like this, and you need to show that the arithmetic, and that you know that the angles along the straight line sum to 180. You cannot use your protractor. Okay, over here, so again this is not to scale, so I can't use my protractor. I've got to show the arithmetic. So step 1 is going to be adding together what I have already, which is 107, 73 and 38. So let's have a look at adding those together. We've got 7 and 3 is 10, plus another 8 is 18. So 18 like that. 0 plus 7 plus 3 plus 1 is 11. And 1 plus 1 is 2. So my existing angles add up to 218. But what does my x angle add up to? Well, I know that all those angles must add up to 360. So my x angle is going to be 360. Take away what I have otherwise, which is 218. 0 take away 8 I can't do, so I borrow from here. That leaves me with 5 over there. 10 take away 8 is 2. 5 take away 1 is 4. And 3 take away 2 is 1. So 142 degrees. Quick look at the diagram. Does that make sense? Yeah, that's an obtuse angle. And 142 is an obtuse angle as well. So my x angle is 142 degrees. Okay, moving on to some different examples now. That should just be a recap from last week. So, we also started looking at angles in triangles. Now, angles in any triangle, doesn't matter whether it's scalene, isosceles, equilateral, right angled triangle, they all add up to 180. The angles in any triangle sum to 180 degrees. So in a very similar way to my other angles questions in the previous example, I'm going to add together what I have already, which is 54 and 98. So let's add together those two angles and see what we get. Well, 4 plus 8 is 12. And 9 plus 5 is 14, plus another 1 is 15. And then to get my x value, I'm going to do 180, because they all add up to 180 in a triangle. Take away 152. And starting with my units on my ones column, 0 take away 2 I can't do. Borrow from here, 10 take away 2 is 8. 7 take away 5 is 2, and 1 take away 1 is 0, okay? So, apologies, that's a 2 there. So my x is 28. Does that look reasonable? Yeah, because my x is an acute angle. Okay, moving down to here. Now I've got an interesting triangle here. I've got little dashes on all three sides. That means that all those sides are equal. But it also means all the angles are equal. Okay, so x, each of those x's is exactly the same value. But I know that all three of them add up to 180, so I know I've got to do actually something slightly different in this question. I've got to do 180 divided by 3, because there are 3 equal angles. And we can do that using a bus stop. So 180 divided by 3, well, 3's into 1 don't go, but 3's into 18 go 6 times. And then I've got my 0 left over. So each of those x's is equal to 60 degrees. And that is, in fact, the size of each and every angle in an equilateral triangle. And as with any of these situations, you can always add up each of those angles and see if it adds back up to 180, see if you got it right. So again, with this one up here, you could do 54 plus 98 plus 28 and see if you get 180. And hopefully you would. Over here, I've got an isosceles triangle now because I've only got markings on 2 of those sides. So straight away, I know that A is going to be the same as that one. So A is 79. I know that straight away. A is 79. But what is B? Well, B is going to be what's left over from the 279s and what's left over from 180. So, step 1, I'm going to add together my 279s. And let's see what that gets us. Well, 9 and 9 is 18. So I'm going to put my 18 like that. 7 and 7 is 14, plus that one is 15. And then I'm going to subtract from 180 to find out what B is. Because B is a cube, so I can't possibly have got the answer to B here, because that is obtuse. I've got to get B from doing 180, take away 158. So let's do that. 0 take away 8 I can't do here, so I'm going to borrow from there. 10 take away 8 is 2, 7 take away 5 is 2, and 1 take away 1 is nothing. So B is in fact 22 degrees. Does it look reasonable? Yeah, it looks reasonable. It's an acute angle, and again, I could always check. If I was unsure, I could always add 79, 79, 22 and see if we get back to 180, and I think probably would. Again, these diagrams are all not to scale, so it might not look like it's 22, but if the diagram says not to scale, you've just got to go with your arithmetic and just be confident that if the numbers add up to 180, then you've got it right. Okay, final example of this triangle here. Again, it's isosceles, but this time I've got this top angle here, and these 2 equal angles are what we don't know. So I've got to start off actually in a slightly different way to what we've done before. I've got to start off with my 180, and I've got to subtract what I know, which is 52. So 0 take away 2 I can't do. I'm going to borrow from here. 10 take away 2 is 8. 7 take away 5 is 2. And 1 take away an invisible 0 here is 1. So I know that F and G together make 128. Now I need to know what they are individually. Well, they're both equal, so I can just do a bus stop division to divide them exactly into 2. So 128 divided by 2. 2's into 1 don't go, but 2's into 12 go 6 times, and 2's into 8 go 4 times. So actually they are both 64 degrees. And again, if you were unsure, you could just do 64 plus 64 plus 52 and see if they add up to 180. And then you would find that they do, and so you'd be right. Final situations I want to show you are these, where you've got a triangle combined with a straight line here. Okay, so they've just extended this bottom line of the triangle a little bit further to create another angle B here. So what am I going to do here? Well, let's just ignore B for the moment, and I'm just looking at this triangle here. Just looking at this triangle that includes A. So I'm going to add together what I have. Again, I'm just starting off by adding together what I have. So step 1, add together what you have. Let's do it up here. Add together what you have, which is 64 and 85, and you get, well, 4 and 5 is 9, and 6 and 8 is 14. So those two together make 149, but to find out A, I've actually got to do 180 take away my 149. And 0 take away 9 I can't do in this situation, so borrow from here. 10 take away 9 is 1, 7 take away 4 is 3, and 1 take away nothing is 0. So A is 31 degrees. So A is 31 degrees here. Does it look reasonable? Yep, it's a cute 31 degrees. And then A and B are lying on a straight line. So to find out B, I can just go straight for doing 180 take away 31. And 0 take away 1 I can't do, so 10 take away 1 is 9, 7 take away 3 is 4, and 1 take away an invisible 0 there is 1. So does that look reasonable for B? Yeah, because B is an obtuse angle. So yeah, B looks reasonable at 149. You might want to think, oh, it's the same as what we got initially by adding these two angles, and you might want to think about why they're actually the same answer there. Okay. Over here we've got an isosceles triangle, and we've got this angle up here. So I've got to start off. I've got to work with what I know, which is 36 in the situation. So start off with 180, take away 36, and let's see what we get. So 0 take away 6 I can't do, so I'm going to borrow from here. 10 take away 6 is 4, 7 take away 3 is 4, and 1 take away an invisible 0 is 1. So that means that both this angle here and F add up to 144. They're both equal because it's an isosceles triangle. So to find out F and its equal angle over here, I need to do 144 divided by 2. So let's do that, 144 divided by 2. Well, 2's into 1 don't go, but 2's into 14 it goes 7 times, and 2's into 4 go twice. So each one of those, F and its opposite equal angle, are both 72. They're both 72. But what's G? Well, G lies on a straight line with F, so it's 180 take away 72, and that is, well, 0 take away 2 I can't do, so it's 10 take away 2, which is 8, 7 take away 7 is 0, and 1 take away an invisible 0 is 1. Does that look reasonable for G? Yes, because it is an obtuse angle. So they are your answers there, 72 and 108. So hopefully you now have some examples